The factory method pattern is a creational design pattern that defines an interface for creating objects, but allows subclasses to alter the type of objects that will be created, providing a way to delegate the instantiation logic to subclasses, enabling flexibility in object creation without changing the client code. So say that we are developing a new Model View Controller backend framework, or MVC framework, to rival the popular PHP framework Laravel. So let's code out a basic solution. So I've created a view engine interface with a render method, and this takes a file name. So this is going to be the file location of our template, and we can pass that template some data, and then this view engine is going to render this template. It's going to pass it the data and turn it into a regular string of HTML and return that HTML so that it can be understood by a browser. And we also have a couple of template engines. So here we have a Blade view engine, which implements the view engine interface with a render method, and here we're just returning view rendered from file name by Blade. And then we have a Twig view engine, so this is just a different templating engine, and then we're just saying view rendered from file name by Twig. And this is all within our MVC framework folder. So this is part of our framework that we are developing. And these view engines will actually be third-party code to our framework, because we are going to be sort of downloading these view engines, installing them into our application as packages. So we would not have access to the source code to these view engines. Okay, so now let's create a base controller class to handle requests made to our application. So let's create a controller, and in here we're going to have a method called render, and this is going to take a file name for the template that we want to render, and we're also going to have some data that we can pass to it. Okay, so first of all, let's create a view engine object that we want to use, and we're going to use the Blade view engine. And then let's actually use the view engine to convert our template and pass it the data, and then convert it into some regular HTML. So we can say var HTML equals viewEngine.render, and then we can pass the file name and the data. And finally, what we're just going to do is we're just going to log to the console this HTML. Okay, so this is our base controller class. So remember, this is all part of our MVC framework that developers can use to create their own back-end applications or APIs. So developers can extend this base controller class to create their own controllers to handle requests to their application. For example, a controller that deals with order-related requests. So let's come out of this MVC framework folder and create a new class called orders controller. And this is going to extend our base controller from our MVC framework. Okay, so remember, this would be some developer creating this, some other developer not related to our MVC framework. They're creating their own, maybe e-commerce application, and they're using our MVC backend framework. So in here, what we can do is we can create a method called list orders. And what I'm now going to do is I'm just going to copy and paste some code in here to save some time. Okay, so this is basically simulating fetching some orders from a database. So we can see here we have a dictionary, and we have the name of the item and the price. Okay, so this is just to simulate fetching some sort of order data from a database. And then below this, we can call the render method, which we have inherited from controller, and we can then pass the location of our template file, so the template that we want to render. So this will be our blade template in this case, because in controller we are using the blade view engine. So this will be a blade view. So maybe we can call this, for example, orders.blade.php, and then we can pass the data that we want to populate our template file with, and that's going to be this orders data. Okay, so I think that is everything that we need to do for now. I've also created a method called getOrder to get a single order by ID inside of here, so I'm just going to paste that in for now just to save again a little bit of time. You can see here this is just another controller method that we can use to get a single order, okay, by ID. And here I'm just simulating getting an order by ID. We're not actually getting it by ID because we don't have a database set up, but it's just to show you a different method that we could add to our controller. So our backend framework code, where our base controller class is stored, we can see here, will be downloaded by developers as a third-party framework. So other developers will be downloading this MVC framework folder essentially as a package so that they can use our framework to create their own applications. And this orders controller is an example of what a developer might create using our framework, where they extend our base controller class. Now, so developers won't actually be able to modify the code directly in this MVC framework folder. So this means that if the developer wants to use a different view engine or template engine, then this solution is poor, because our controller class is tightly coupled to this blade view engine, and it cannot be changed by developers. The developer has no way of switching to a different view engine. So for example, if they want to use the Twig view engine to create their templates using the Twig templating language, then we have provided them with no way of switching to a different view engine. So let's try a different approach. What if we allowed developers to pass a view engine as an argument to the controller.render method? So currently we have the file name and the data that we want to pass to the view, but let's also allow the developer to pass the view engine that they want to use whenever they render a view. So let's pass the view engine that we want the developer wants to use, and now we can actually remove this view engine. We don't need to create the view engine because it's been passed here. And then, just as before, we can call viewEngine.render, and then we can log the resultant HTML to the console. So this allows developers to select a view engine every time they call this base controller.render. So if we come into our orders controller, we can see that we now get an error because we are not passing the view engine that we want to use. So the developer now needs to pass the view engine that they want to use, and if they want to use the Twig view engine, for example, they can pass the Twig view engine. So here we can pass again the Twig view engine. So this is a more flexible solution because it allows the developer to choose whatever view engine that they want to use. However, the problem is that we have to now pass, or the developer has to now pass, the view engine every time they call the render method. And usually developers will be using one view engine for all of the templates in their application. So it doesn't make much sense to make the developer to have to keep passing a view engine every time the render method is called. So the solution is to create a template method, and we can add a create view engine template method inside of our base controller class. And by default we can return the blade view engine. But if the developer wants to switch to a different view engine, such as Twig, then they can use our alternative controller class, Twig controller, that overrides the create view engine template method. So here is the UML, and you can see here we have our base controller class, which is part of our MVC framework package, and we have our render method just as before, and we also have our create view engine method, which by default returns a new blade view engine. So if the user doesn't specify any different view engine, then they will get the blade view engine. And also within our MVC framework package, so this is part of our package, our backend framework code, we're going to create a twig controller which extends the base controller and overrides the create view engine method, and instead it returns the new twig view engine instead of a blade view engine. So if the developer wants to use the twig template engine, then they can extend the twig controller instead of the regular base controller. So create view engine is our template method. Let's show this in code. So let's now refactor our code to follow the template method pattern. So let's actually remove this view engine parameter from the controller's render method. And we're actually now going to use a template method to create our view engine. So this is going to be a protected virtual method that returns a view engine, and it's going to be called create view engine. And by default, the default implementation is that we return a new blade view engine. So now up here we can create our view engine by calling this create view engine method. Okay, so by default the view engine for our framework will be blade. Okay, so now we can actually create our alternative controller that the developer can use. So we're going to create a twig controller. So this is going to extend our base controller class, and we're going to override the create view engine template method. So we're going to say protected override view engine. So it's going to return a view engine, and it's called create view engine. Okay, so what we're going to do here now is return the twig view engine. Oops. Okay. So now if the developer wants to switch to the twig view engine, they can extend our twig controller class rather than the base controller class. So if we go into our orders controller, we can see here we are getting an error because we no longer have three parameters in this render method. So we can remove this last argument because we no longer need to specify the controller type in the render method. And if we want to use the twig template language now, we can just extend the twig controller, and our render method will use the twig template language because this create view engine is a template, meaning it can be overridden and it will affect the behavior of the render method because we are calling it in here, and this can return different types of view engines depending on whether it is being overridden or not. So essentially, as we've said, this create view engine is acting as our factory method as it returns a new object. Okay, and it can be a different type of object depending on if we override it or not. So essentially what we've done is we've deferred the creation of an object, the view engine, to a subclass, and in this case the subclass is twig controller because it's a subclass of the base controller class. And another option would be to make this create view engine method an abstract method and force subclasses to implement it. So in this case we have made it just a regular method, and we've provided the virtual keyword, meaning that it can be overridden. But we could also make it an abstract method with no default implementation, so no body essentially, and force subclasses to implement it. So in that case, we'd need to create a blade controller that implements this createViewEngine method and returns a blade view engine, so that it would force the developer to select either blade view engine controller or the twig view engine controller. Here is the gang of 4 representation for the factory method pattern. So we have some creator class which has an operation method that calls the factory method, and you can see that a factory method returns some object. And then we have our concrete creator classes which can override the factory method from the creator class. And you can see here each factory method can return a different type of object. And you can see here the factory method is called inside of the operation. So essentially we can change the behavior in the creator class by overriding this factory method. So the objects returned from factory methods are referred to as products in the Gang of 4 book. And the factory method pattern is often misunderstood. It relies on inheritance and polymorphism to add flexibility to the design. Inheritance allows methods to be overridden in subclasses, and polymorphism allows different objects to be returned from the overridden methods. And many people implement the factory method pattern incorrectly, for example using a static method such as this. So var engine equals view engine factory dot create view engine. But static methods cannot be overridden, so there's actually no flexibility when using a static method, and it isn't correct. Because we cannot change the implementation of the create view engine method. So using the factory method pattern, we can defer the creation of an object to its subclass or subclasses, and this is possible through inheritance.